8.1 Similar polygons. Essential question: how are the sides, angles, perimeters, and areas related in similar polygons? Corresponding parts of similar polygons. Corresponding parts are corresponding angles, which are congruent. Every angle in this triangle is congruent to every angle in here. And the ratio of the sides are all the same. So if you compare DE to BA and so on, they all have the same what we call scale factor. This is the same thing what we saw with dilations when we were looking at transformations. When one triangle is dilated to another, there is a scale factor associated with it. Let's take a look at this problem and try to find the scale factor for these two similar polygons. Now, the similarity symbol looks like this. Notice how it's different from the congruent symbol, and it means that all angles are congruent and all sides are in the same proportion. All right, so let's go ahead and find the scale factor. So I know RS, which is the first two letters of this triangle, will be to the first two letters or the side, and that will be the same as the second two, very similar to what we did with congruence, but now that's a ratio. Now the sides are RS, and RS is 20, and XY is 12, ST is 30, and YZ is 18, RT is 25, and XZ is 15. And I want you to notice when we reduce this, this will be 5 to 3, and 6 goes into their 5, 6 goes into their 3, 4 goes into their 5, 4 goes into their 3. They all have the same ratio. So we say that the scale factor is 5 to 3. You only needed one pair of corresponding sides to do that, but I did show you all three. Now all the congruent angles, so I just look at the similarity correspondence, and angle R will be congruent to angle X. Angle S is congruent to angle Y, and angle T is congruent to angle Z. And I've really already written the corresponding sides when I did it up here in red. And that is called the statement of proportionality. Okay, your turn. Try to figure out the scale factor, list all the pairs of congruent angles, and write the ratio of the corresponding sides. Stop the screencast. And here is the answer. Here's the statement of proportionality. When I take a look at these letters, the scale factor ended up being to 2 to 3. You really only need one pair to do that once the triangles have been established to be similar. And here are all the congruent angles. Corresponding lengths in similar polygons means that the ratio of two corresponding lengths in the polygons is equal to the scale factor. Okay, so let's take a look at this and try to figure out, using the scale factor, try to figure out X. So we know DE, here's the statement of proportionality. DE is to MN, as EF is to NP, as DF is to MP. Let's go ahead and put some numbers in. DE is 15, and MN is 18. I'm going to go EF, which is X, that's what I'm looking for, and NP is 30. Now there's two ways you can do this. One way is to just cross multiply. So I'll do 15 times 30 is equal to 18x. And then what I like to do is I like to divide both sides by 18. And while I'm doing that, I'm going to reduce. So 6 goes into here 5 times, 6 goes into here 3 times, and I can still do some reducing. 3 goes in here 1 time, 3 goes in here 5 times, and the answer is 25. Another way I like to do it is I like to reduce before I cross multiply. So 3 goes into here 5 times, 3 goes in here 6 times, and then I take a look and I'm saying what number times 6 makes 30. So, and I know that number is 5. So if I multiply the bottom by 5 to get the 30, I must multiply the top by 5. And so I get X equal to 25. So these are two strategies to help you with proportions. You can do the cross multiplying, or you can reduce if possible, and then take a look at making the fractions equal to each other. All right, let's take a look at this problem. The triangles are similar, so I've already written out the uh, corresponding proportion. And I also know that the altitudes have this same ratio, so I wrote this down. I know that TR, which is 12, and XZ, which is 16, is equal to the same proportion or same ratio of the altitude, which is X, what I'm looking for, and 20. I've decided to take a look at reducing 12 over 16, and I noticed that all I got to do is times by 5 to get the 20. I'm going to times the top by 5, and then the answer is 15. All right, your turn to try to figure out the value of x or km. Stop the screencast and see what you can do. And here are the answers. Notice I write the statement of proportionality, I substitute. You can either cross multiply, reduce, and then figure out the answer, either way. Okay, let's take a look at the perimeters of similar polygons. So what this is saying is that the ratio of the perimeters is the same as the ratio of the corresponding sides. Let's take a look at a problem in which we do this. We have an Olympic pool that is 50 by 25, and another pool is similar in shape and its length is 40, and we'd like to find the perimeters of the Olympic pool and the new pool. Well, the Olympic pool, so I'm going to call this the large one, is going to be 25 plus 50 plus 25 plus 50. So altogether it's going to be 150. And the question is to figure out the perimeter of the small. So what we've been told by the previous slide is that the perimeter of the large over the perimeter of the small is equal to the side of the large over the side of the small. And so I'm going to write 150 all over perimeter of the small, and I'm going to relate corresponding sides. So I'm going to write 50 over 40. Now I'm going to reduce this fraction right away, and I can see that I have a 5 up here, and to make it 150 I'm going to have to multiply by 30, and that means I'm going to multiply the bottom by 30 to get the perimeter of the small, and so the perimeter of the small will be 120. Notice that I got the perimeter of the small and without me having to find the missing side. All right, your turn. See if you can find the perimeter of gazebo A. Stop the screencast. Now here's the answer. Again, I wrote down what I knew, the perimeter and the side, and I'm relating this side to this side 10. These are the things I know and I don't know, and I set up my proportion and I go ahead and solve and get the perimeter. Okay, let's move into cake right here. We're taking a look at the top of the cake, and we're taking a look at the ratio of the sides of the top of the cake, the perimeters, and the ratio of the areas. So I can see that the ratio of the sides is side of the large to the side of the small is 3 to 1. So this is 3 times as big as this one, the sides are. Now, if you do the perimeters and you add up all of this and you add up all of this and compare them, 3 to 1, which is what we've been talking about. The question I'd like you to think about is, what do you think the ratio of the areas are? Stop the screencast, make a guess, and then continue. Now, I'm going to multiply the area of 27 times 39, but I'm going to do it in an interesting way. I'm going to say 3 times 9, which is 27, and 3 times 13, which is the 39. And then the area of the small cake is 9 times 13. Now, before multiplying everything out, I'm going to take the 2 3's and pull them out here, so associate them in the front, and then 9 times 13. Now, you're going to see that I can do some reducing. And when I reduce, I'm going to get a ratio of 9 to 1. So the ratio of the areas is not the same as the ratio of the sides or the ratio of the perimeters. In fact, it's the square. And that's what leads us to our next principle, which says that the ratio of the areas is equal to the squares of the ratio of the sides. So take the ratio of the sides and square it, and you'll get the ratio of the areas. Let's take a look at this problem. We want to find the ratio of the area of triangle EFG triangle DEF. So the area of the large over the area of the small is equal to the side of the large over the side of the small quantity squared. That's because we're dealing with area. So this is 36 over area of the small, and area of the large is 10 over 5 squared. So when we reduce this, this is going to be 2 over 1, and then that'll be 4 over 1. So I have 36 over area small equals 4 over 1. And I know that when I multiply the top by 30, not 36, but I have to multiply it by 9, I will get 36, and I'll multiply the bottom by 9. So in other words, these two are equal to each other, and these two are equal to each other. So the area of triangle DEF will be equal to 9. All right, your turn. Go ahead and see what you can do to find the area of LMNP. And here's the answer. Notice how I set up the formula, the ratio, and the proportion, and then I substitute the numbers, do a little reducing, and then go ahead and find my value. In this case, what I had to do is just cross multiply. So I just did a cross multiply to figure out the area of the large. Okay, last problem. We want to decide if these two figures are similar. And the answer is, well, all their sides have the same scale factor, 2 to 3. But they are not similar, and that's because you have to take into account angles as well. Even though they have one angle in common, you would think that maybe you could reflect it and it would look like this. But unfortunately, angle N and angle R right here, these two angles don't necessarily have to be the same. Notice how this angle right here isn't quite the same as this one. All right. So the lesson to be learned here is even though sides are all congruent, you also have to consider angles. Sides have the same ratio. The angles have to be congruent.